What lifts a drone the instant the wind kicks up? Or what tightens a robotic grip the moment metal meets pressure? Or what turns a raw brain impulse into a smart home command? All of it begins with just one primitive spark in code. It's a function. Welcome to the series. In the last video, we laid out the vision, how to build real-world systems that think, sense, and act. Today, we take the first step, or the first real step, not with AI or fancy libraries, but with something deceptively simple. It's the function. Because when a machine needs to make a decision or perform an action, this is actually what it runs. Imagine this: you touch a hot stove. Before you even think about it, your hands pulls away. That's not a conscious choice. It's a reflex. Your body senses the danger, processes it, and then instantly act. So it's like sense, compute, act. That sounds familiar, right? That's what machines do. So that's exactly how machine works too. In C++, that reflex, it has a name. It's called a function. Function is like the little brain. You give it some inputs, like those inputs could be temperature, speed, distance. It runs the logic, fast, invisible, reliable logic, and then it gives you an output or triggers an action. Those action could be started the motor, or flash the warning light, or sends a message. So functions are how we teach machines to do anything, not just math, but behavior, from the smallest temperature check to stabilizing a satellite. How does this actually work? Well, let's start building our first example, and we'll be building a function. First, we're going to start with include IOStream and using namespace std. Okay, so include IOStream stands for input output stream. This line opens the channel between our code and the outside world, and as I said, it stands for input output stream, and it's basically how the machine finds its voice. It lets our program speak out loud through cout or listen quietly through cin. Think about it like a nervous system for communication. So this line connects thought to expression. And for using namespace, here we extend a little bit by basically removing the formalities. So basically we're saying, I trust you, let's speak informally. So instead of saying std cout and then we call something, we're just going to say cout and then we call, let's say, result, and we end the line, something like that. Okay, just to keep things clean and simple and fast for now, for the sake of the example. Okay, next we're going to be saying add and then integer a, integer b. So, and then we open a bracket. Okay, so this is our first function. Here basically we define our first reflex. Integer, or int, in the beginning of before the add means the function will return a whole number, and that number is an integer number. Add is the name of the function, which is the name of the behavior that we are trying to build, and basically what it does. So you can name it anything. So here I named it add, and integer a, int a and int b, basically these are representing the inputs. Okay, so this function takes two numbers or two inputs, right? And then inside that function, we're going to say return a plus b. Okay, so here, this is basically the brain of the behavior or the reflex. When it runs, it adds those two inputs and sends back the answer. No thinking, just reaction. Okay, it may look simple, but imagine if A was and B was like a heartbeats data per second, or a pressure from a robotic finger, or you know, or like a pressure sensor for like, or a humidity sensor or temperature sensor value. So this is not just math, this is like behavior. And yeah, so now we'll go to the next function, main, and this is very important function, and then we open a bracket. So here, integer main is basically every C++ program begins here with the main. It's like the ignition switch, the place where code becomes action. The as I said, the int tells us like this function will return a number, and usually 0, back to the system to say, hey, I'm done, I finished, and it's successful, or I finished my task. And I'll show you here, we'll be basically saying integer result equal add 5 and 3. So here, what I did is that we're calling basically the function above, and we're storing the answer in a result. Okay, so then we're giving the two inputs, two values, 5 and 3. You can change those numbers as you want it. So it's just two numbers, 5 and 3. Okay, and we finish that with cout result equal, and then here I would just add result, and then here I end the line, and then I would just say return 0. Okay, so here cout, now basically what we're saying is like the machine is speaking, as we talked about, is like cout is basically we want to see what the function is doing. So cout means a console output. Okay, so it's the stream. Think about it like a river carrying the words outward. Okay, and we tell the outside or the world what the machine calculated. Okay, that's like a first echo of artificial thought. And then and then return 0, that's like a signal that everything is completed successfully, and the system knows that I'm done, I ran, and I made a choice, and that's the formal basically goodbye. Okay, now if we run this, all right, now we're gonna run it. It says result equal to 0. And then if we change that to, let's say here 10, and then we save that, run it again. All right, now we got 15. So that's the machine right now speaking and giving us the results. It saw the output, the inputs, made a decision, and told us the answer. Okay, and I want you to think about it, because think about this. 5 and 3 is just numbers, but that's just math. But what if we give this machine something real to react to? And let's basically raise the bar a little bit, and let's say that this machine controls a drone, and that drone is trying to hover in the midair. Suddenly, the numbers aren't just values. They're gravity, they're going to be altitude and force, to find the force, for example. So how about we try that same principles as we did here, but we're going to try it building real world example. And what we can do is we can delete that, and then we start basically building our first real world function to compute hover thrust, and then we'll give it float weight in kilogram, and then float altitude. Okay, so what are we doing here? So here, and then we can return something. Okay, so here's the new function. Compute hover thrust. This is how the drone knows how hard to push to stay in the air. Okay, and float means we're dealing with decimal precision. So in the past we were saying integer, but here we're saying float because that's physics and not integers, and they're real world values and not just integers. The inputs that we have is weight in kilogram, the weight of the drone, and the altitude, or the current altitude of the drone at that particular time. So these values the drone reads from its sensors. Okay, the return line is simple physics. So it's going to be basically 9.81, which is the gravity times the weight in kilogram plus 0.03 times altitude. Okay, and done. That's it. Now we're gonna go down. As always, we're gonna simulate this in action, and we're gonna write main, open the bracket. Okay, this is just like the last example. We start with the main and the ignition point of every system. Okay, and inside we're gonna give it a situation. Okay, the drone weight. Let's say first let's write float thrust equal to compute. I'm just calling the function. Okay, and then I'm giving the values to it. But what are those values? Let's call them. Okay, float, let's call it drone weight is equal to 1.5, and this is going to be in kilogram. Okay, and then we have a float, and that's going to be the current altitude. Okay, and that's going to be, let's say, 100 meters. Okay, so inside we're calling the function here, and then when we call it, we're just giving it a name, and we call it thrust. And also we give to the name or the outcome, or the type of the outcome is going to be float, because we're trying to return a float. Okay, and inside is going to be basically the drone weight and the current altitude. Okay, now, so right now if I say return and 0, this should be it. However, I cannot see the values. I cannot see if actually the thrust result or the result of the thrust is actually the correct values. So what I do is I want to call it out and see in the console. So see out, we can just say thrust required equal, and then I can just here I can just say thrust, and then I can end the line. Okay, so let's try it out. All right, so the thrust required is equal to 17.715. Okay, so the program ends, decision was made, and the action is clear. Okay, and basically that's a raw reflex from physics to command. The drone knows exactly how much force in Newton to apply to stay stable in the air. Every function you write in C++ is like this, whether it calculates thrust, detects collisions, or checks sensor readings. It's a reflex, a decision-making loop that connects the machine into its environment. In embedded systems, these run thousands of times per second, tiny, fast, predictable pieces of logic, and together they make the system feel alive. In the next video, we will go one step further. We'll write functions that don't just respond with values, but they act. Imagine like they spin a motor, or they flash lights, or they trigger alarms. We're going to move from reaction to interaction. I'll see you guys in the next video.